Hello everyone. Today, we are excited to demonstrate the capabilities of our Azure AI agent service, specifically highlighting our new SharePoint and Microsoft Fabric integration. As we delve into these updates, we also discuss a shift we are seeing in the field of AI, from Retrieval-Augmented Generation, what we call RAG, to Agentic Retrieval-Augmented Generation, known as Agentic RAG. We are going to see how Azure Agent Service makes it easier to build this new agentic system for the enterprise. This evolution addresses the increasing complexity of enterprise retrieval challenges. In many enterprise scenarios, a single task might require accessing multiple data sources at scale, a structure and unstructured. To generate the most informed and accurate responses, Agentic RAG makes this possible by shifting us from linear to adaptive workflows, from one-shot answers to iterative refinement, transforming static, search-augmented LLMs into enterprise context-aware systems. Whether your data resides in a data warehouse, a semantic model within Microsoft Fabric, a vector index in Azure Search, or documents in SharePoint, Azure Agent Service empowers enterprise to autonomously plan, retrieve, and reason across their increasingly distributed set of data, turning fragmented knowledge into unified, actionable intelligence. Let's understand how Azure Agent Service and Agentic RAG can transform the day-to-day work of a product manager in research and development. For context, imagine I'm working at a leading medtech company managing product A, a next-generation continuous glucose monitor designed to help patients with diabetes monitor their blood sugar levels in real time. Now, picture this scenario. I just led a high-level strategy meeting where we are planning the next evolution of our product. At the same time, we are closely tracking competitors that's starting to gain significant market attention. Before making any decision that could save the product of Product A, I need to quantitatively and qualitatively assess how it performs compared to Product B. In other words, understand why it might be performing better or worse, particularly across specifically glucose ranges. At a high level, to answer this meaningfully, we need to retrieve clinical insights from platforms like Microsoft Fabric, where our sensors and clinical trial data is stored, SharePoint, where meeting notes and research documents live, and Bing for external market research. Validate and cross-check data for accuracy and consistency across these diverse sources. Synthesize findings into actionable insights, dramatically reducing the research to decision cycle. Let's see it in action. We're going to jump into our research and development intelligent assist powered by Azure Agent Service. I'm going to start with prompting our Agentic RAG with a question from our previous meeting. Which glucose range does Product A underperform compared to Product B, and what clinical impact could this have? While our agents are doing the work, let's review our data sources, Microsoft Fabric and SharePoint. As you can see, we have glucose analysis and structured data available in Fabric to analyze trends, compare product performance, and answer user queries related to continuous glucose monitor. We also have unstructured data and documents from different teams available through our SharePoint site. Our multi-agent AI system is built on Azure Agent Service, which acts as our microservice-based enterprise single-agent orchestration layer. It allows us to build retriever agents that access data available in Microsoft Fabric, SharePoint, vector databases, and the web through the planning and execution of tools. A key aspect of this single-agent architecture is on behalf of authentication, which ensures secure and precise data retrieval across platforms. Additionally, leveraging the Fabric connector through the data agents allows us to access enterprise structured data, currently supported Lakehouse, Warehouse, Semantic Model, and even House DB within Fabric, unlocking countless possibilities for data integration in our AI applications. Now, to connect the dots between these single agents and enable communication among them, we use the Semantic Kernel Agent Framework, or you can use your own. The result is a multi-agent system following the principle of an Agentic RAG architecture that enables intelligence real-time interaction between structured and unstructured data sources, ranging from Microsoft Fabric all the way to SharePoint. Let's come back to our research and development intelligent assist and review the results. For our first step, we'll review the initial query and agent selection. The system selected Fabric Data Retrieval Agent and SharePoint Data Retrieval Agent. As you can see, it was able to understand the nuances of my question and route it to the appropriate data retrieval agents. Next, let's analyze the data retrieval agents. It queries Microsoft Fabric for structured data, gathering insights such as glucose ranges by product. At the same time, it accesses SharePoint for white papers, research documents, and design blueprints, and brought it in a comparative analysis conducted by our research team. For our third step, let's see how our verified agent was able to validate and gather our insights. Our verified agent checked if the data made sense and matched across sources. It compared structured data from Fabric with unstructured content from SharePoint, flagged any issue, and could even adjust the original query if needed. In this case, the data was consistent, relevant, and fully supported the user question and the device performance. Now, we can move on to the next step of generating the summary and final recommendations. We can see an final AI-generated response compiled, summarizing key findings. For example, it clearly demonstrated the underperformance of product A, helping me in critical decision-making. The final report was also sent to my email, showcasing the agent's ability to act, not just analyze it. And finally, to top it off, our systems enable follow-up in interactive Q&A session. Based on my previous answer, I would like to follow up with a specific question. Can we pull the latest clinical studies or real-world data from recent publications to identify emerging trends or new materials that could improve products' A accuracy in a specific glucose range? Thanks to real-time connections with internal and external data sources, the system provides the most current and relevant information ensuring I also have access to the latest insights at my fingertips. We have demonstrated how Agentic RAG, powered by Azure Agent Service, can drastically improve the efficiency of enterprise research and development operations by enabling intelligent data retrieval, automated validation, faster decision-making, and seamless cross-department collaboration. It reduces timelines from months to hours, enhances go-to-market strategies, and strengthens decision-making. While our demo today focuses on medtech research and development, this framework can enable teams across manufacturing, energy, and financial services to move faster, make better decisions, and unlock innovation at scale. We can't wait to see what you build with Azure Agent Service.